Okay, so this is like a problem where two guys are pulling on either end of the box. The mass of the box is given. The guy on the left is pulling with a tension. That's what TL means. Tension on the left of 250 newtons. We're trying to find TR, the tension in the rope on the right. Okay, these are given. The coefficient of friction between the green box and the 4. Okay, so this series of problems for this picture is going to always find the tension in the rope on the right. Okay, so let's look at number 1. Find TR if the box is on the verge of moving. So it's not moving yet. So if we do a free body diagram, there's the box, there's TR, there is TL, there's the weight, there's the normal force. So there's also friction. So if it's on the verge of moving to the right, the friction is in what direction? To the left, opposing the way it would slide, the direction that it would slide. Now, that's static friction, and actually a static friction max, because it's not moving yet. It's on the verge of moving. So we can solve for, we're looking for TR. We got TL is 250, that's given. The weight is equal to the mass times g, acceleration due to gravity. So it's 30 times 10 equals 300. Normal force is equal to the weight. It's equal to 300 newtons. The static friction maximum, look at the equation, is mu s times n on your equation sheet. Excuse me. So it's 0.70 times the normal force, which is 300. That's 210 newtons. Okay, so we're trying to find this guy right here. Now, it's at rest. So if it's at rest, the forces are balanced. The left pointing forces are balanced by the right pointing force. So I can say tension in the right rope is equal to the tension in the left rope plus the Fs max. So that would equal 250 plus 210. So my final answer would be 460 newtons is what the tension in the right rope would be. Okay. This next question is the same kind of thing. So, but let's say the box is on the verge of moving to the left, but it's at rest still. So it's not moving to the left, it's on the verge of moving to the left. So we still got TL, we still got TR, but because it's on the verge of moving to the left, there's the maximum static friction pointing the opposite direction of which it would slide. So it's on the verge of moving to the left, so the static friction is pointing to the right. So same idea as before. These forces are balanced because it's at rest. So TL equals TR plus Fs max. TL is already 250. TR is what I'm looking for. And Fs max, you already figured it out. Above 210. So TR is equal to 250 minus 210 is 40 newtons. Okay? Now, I'm going to have it moving for part 3. What if the box is accelerating to the right? So, let's draw the free body diagram. So the acceleration is to the right. So the net force has to be to the right. And so TR is going to have to be bigger than the force is pointing to the left. Okay, so let's see. What kind of friction is it? It's moving. So it's moving to the right. Well, let's say the box is moving to the right. It's accelerating to the right. So TR has to be the bigger force. Now, which way is the friction pointing? Well, to the left. But it's kinetic friction, not static friction, because now it's moving. So, and the forces do not balance out because you're accelerating. So, TR actually is going to be bigger than the sum of those two. So let me draw it significantly bigger. So TR, let's do it this way. So net force is equal to ma. I can use this equation now because I have acceleration, 1.5, and the mass is 30 kilograms. So 30 times 1.5 is 45 newtons. Now, don't stop there. Now, I use the equation with my diagram, my free body diagram. So TR minus TL minus FK is equal to unbalanced force, which is 45. We just found that. TR is what I'm looking for. TL is 250, same as it was before. And FK, I gotta find that. FK equals mu K times N. So that equals 0.42 times 300. 0.42 times 300, because the normal force is the same as the weight. Okay, so that comes out to be 126 newtons. So I'm going to put that up here. And so let's calculate over here. Let's go over here. So 45 equals TR minus, what's 250 plus 126? 376. So TR in this case is going to equal 45 plus 376. I'm getting 421 newtons. So, okay, the next question is the tug of war. I'm trying to tell you that the tension that this team is pulling with has to equal the tension that this team is pulling with, because that's Newton's third law. I think I said that right here. Okay? The tension in the rope between the two teams pulling is the same because of Newton's third law. So I said that right there. Okay, find the maximum static friction between the ground for the ground and each team. So here's the girl team. The maximum static friction is equal to mu S times N. N's the weight, right? Which is mg. So for the girls team, the weight is 90 kilograms. That's the mass. So you multiply that by 10. So that's 900 newtons. Okay, mu S for the girls team is 0.7. So 0.7 times 900 is 630. Okay, so that's 630 newtons. Okay, I do the same thing for the boys team. The boys team, the FS max. The maximum static friction is equal to 0.4 times 1300. Okay, I'm doing the same coefficient of the same equation, but their coefficient of static friction is 0.4, and their mass is 130. Multiply that by 10 for the weight. So 0.4 times 1300, you get 520. Okay, so what team has more friction holding them, keeping them in place? What team has more friction, the one with 520 or the one with 630? Well, the girls' team, the one with 630. So find the friction between the ground and each team when the tension is 300 newtons. Okay, so let's look at the girls' team. So here's the girls' team. Okay, here's the tension. And what's the friction? Okay, well, they can get up to 630 and not slip. So if 300 is pulling them that way, the static friction won't be maximum, but it will equal that because they won't move. They only move if this tension right here exceeds 630. It doesn't. It's only at 300. So since it's at rest, the static friction is 300. Okay, that's the girls' team. The boys' team, the tension's pointing that way, same tension, 300. And let's see. The boys' team can fight that up to 520, so the boys' team will have 300 newtons that way as well. Okay, so both of them will be at rest with the static friction, not the maximum static friction, but the static friction being 300 newtons. So neither team will move. Okay, number 3. As the tension is gradually increased from 0, which team will start moving toward the other team? Well, the one with the less friction, and that would be the boys. The boys will lose eventually. So the boys' team. Now think about it. Once it passes 520, the girls will still be at rest because they can resist up to 630. But once it goes past 520, the boys are sliding. Calculate the threshold tension that will, if exceeded, cause that losing team to slide. Okay, so the boys can only withhold a friction, a static friction max of 520 for the boys. So I got that up there in part A. Okay, so the tension, once it exceeds 520, they're losers. They're sliding. But the girls will, here's the tension on the girls. They'll have 520. But they can go up to what? They can go up to 630 newtons right here. And so they're good. They'll stay in place. Okay? So that tension is 520 newtons. That's my answer. If the acceleration of the losing team is 0.5 meters per second squared, what will be the tension in the rope? Okay, well, we already established it would be the boys. So here's the tension in the rope. That's what I'm looking for. And the friction that they're holding back, okay, they're accelerating already. So that tension is going to be greater than the friction. And so they'll be sliding. So that will be FK. That will be FK because they're sliding. They're accelerating. They're losing. So FK, I didn't figure that out yet for the boys. It'd be UK times N. Okay, coefficient of kinetic friction for the boys is 0.3. The weight of the boys, the normal force of the boys, is 1,300. We did this before. So 0.3 times 1,300 is 390. Okay, so the net force is equal to the bigger force. It's accelerating to the left, right? It's accelerating to the left. So T is bigger than FK because T is in the direction of the acceleration. So net force is also MA. So what's the mass of that team again? It's 130 times acceleration of that team is 0.5, opposite in the negative direction. It says right here. Okay, so that equals T minus the kinetic friction, 390. So 130, that'd be 65. 130 divided by 2 is 65 equals T minus 390. So T equals 390 plus 65. Is 455 newtons. So that'd be the tension in the rope as that team is sliding with an increasing speed to the left, accelerating to the left. Okay?